PowerShell scripting, custom formatting views. Now, if you've been working with PowerShell through these 60 odd preceding nuggets, you've probably hit a very common point of frustration, which is you spend all this time putting together a great function or tool, but the output looks ugh. Well, I've got an answer for you, and it's called custom formatting views. It's going to leverage the same technology in PowerShell that lets it display such nice default output for many of its commands. Now, to make this make sense, I'm going to start by showing you how PowerShell's internal formatting actually works. What we're going to find is that PowerShell is capable of applying any default formatting we want to a particular object, provided it can uniquely identify that type of object, which is going to require us to add a custom type name. And then I can get on to actually showing you how to make those views and how to load them into memory, both manually and, this will be the cool part, automatically as part of a module manifest. Let's dig in. Now, everything I'm going to show you has been true since PowerShell version 1. I'm going to work here in Windows 8 because it gives me a good ISE to work in, but everything you're going to see here will work in pretty much every version of PowerShell. So here we go. When you run a command to get process, sometimes you get some pretty nice output. Now, I want to point out something that's interesting here. If I do PS, and I'm just going to select the first one so that we don't get a screen full of information, and I pipe it to format list star, this is actually the raw data. So you're going to see properties like VM, and these are clearly bytes, right? That's virtual memory, working set, paged memory, non-paged memory. These are all clearly byte values. But if you look at the default output of getProcess, it's changing them into kilobytes. Virtual memory is in megabytes, CPU is in seconds, and these headers have the little parentheses with the unit of measurement in there. Those aren't actually part of the property names. There's no property called PM parentheses K close parentheses. The property name is just PM. Well, so where does all this come from? Let's open up a new shell. We'll leave that one sitting right there. Make this one a bit smaller. I'm going to change to PowerShell's installation folder. And in here, you're going to find a number of files with the file name extension .format.ps1xml, including one called, and we're just going to look at it in Notepad, .NET types.format.ps1xml. Now, the trick to this is to run, let's leave that there. Let's run get process and pipe it to GM, because the trick of all this is located in the first line of output of get member, and it's this, the type name. Let's put that on the clipboard. Go back over here in a Notepad and do a find. Right here, we have got a view named process. Now, the name is not actually significant for us. What's important is that this view is selected by objects having the type name system.diagnostics.process. In other words, when PowerShell needs to display an object of this type, this is the set of instructions that it is going to use to do so. Let's see what's in here. It says it's a table control. Well, that makes sense because we're looking at a table over here on the left. It's got 1, 2, 3, 4, 5, 6, 7, 8 columns ending in process name. So the headers for this are handles. That's been set to 7 characters and right alignment. We've got npmk, pmk. Right? These labels are exactly what appear as the column headers. That's the magic of this. It's more magical as if I can get the window out of the way. 10 characters wide, some of them have right alignment. Left is the default, so when it wanted left, it just didn't specify anything. Now here's a tricky bit. Everyone misses this. Try not to miss this. Here's a table column header. You will notice that unlike every other one, it does not have a label. See, the rest of these have got a label and a label and a label. Well, because this one doesn't have a label, it is going to merely be 6 characters wide and right aligned, and it will use as its label whatever property we tell it to put in there, and this is the ID column. The last column is right here. This one's hard to miss because it doesn't have the opening table column header and the closing table column header. It's just a table column header that self-closes. That means PowerShell should use the property name as the column header. It should figure out how wide it needs to be on its own, and it should align it however it wants to, meaning strings get left aligned and numbers get right aligned. The next section of this XML decides what is going to go into each of those. So the first column, so we've got a table column item, the first one, we're going to put the handle count. So there's no property called handles. This header came out of the XML file. The property being used to populate this is called handle count. The next one is a script block. It's not using a property name. Look how this one used a property name. And look how this one is using a script block. It's executing this code. It's taking whatever the npm property was, dividing it by 1024, and casting it as an integer. That's why we get an integer here with no decimal points. It's doing the same thing for the PM column, the WS column, and the VM column. And then, let's scroll down a little bit more. And I'm going to have to scroll back to the left. This next one here, the CPU, if the CPU does not equal nothing, then convert it to a string that has a number. So that's how it's doing that, because you'll see some of them like idle here. See, it has nothing. If I tried to convert nothing to a string, I'd get an error message. So it has that little script block there. Now the last one is putting the ID and the property name, and the last one is putting the process name as property name. So that's how all these get populated. And the important thing is that there are 8 column header definitions, including this easy to miss one. Therefore, there are also 8 table column items. They have to match. All right, let's do this. Let's have some fun. We'll shrink this down. Let's pull up my ISE. We're going to create a custom formatting view. I'm going to start with a new file. Now, trust me when I tell you, you're probably going to need to refer to this file name a lot as you're testing. You can put this file in its final location later. For now, I like to put it in the shortest path possible, which is the root of my C drive, because I'm just in a lab virtual machine. So I'm going to call this myview.format.ps1xml. I'm saving the empty file for a reason, and it's because doing so will allow PowerShell to color code this thing properly for me. Now let's go start pilfering. These Microsoft files, like this one I'm looking at, have a huge digital signature at the end, and that means it's important you not mess with these in any way, shape, or form. They must not be modified. So don't mess with this and then save it. I'm going to start by copying the first chunk of this. Copy, paste, and I'm going to delete this little copyright notice. Bye-bye. So I've got my XML declaration, my opening configuration tag, and my opening view definitions tag. And you'll notice I've got a little red squiggly behind each of those because it says the end tag is not found. Well, XML, everything comes in pairs. The beginning tag just has a name, and the closing tag is a slash followed by that same name. And they've got to be nested. If I take this and put it here, it's broken. End tag view definitions was expected first, idiot. So I'll undo those. Now all the red squigglies go away. Everything in your configuration file is going to come inside here. Everything goes in the view definitions. Let's go back to here, and let's make a custom table view for ourselves. I'm going to go grab the one from processes. So you're going to start with the top view tag, which is right there. That's the opening view. And you're going to scroll all the way down until you get the closing view tag. Copy. Paste. Now I'm going to be working with this script. It's the same one I showed you in the previous nugget. And let's see, we've got a bunch of information being displayed by default. I'm just going to get a pen. Hang on, I got a piece of paper around here somewhere. Ooh, Post-it notes. I love these things. All right, I want to display, let's see, I want the computer name, so I'm going to write down computer name. I want the SP version and the OS version. And I don't want to try and cram too much on the screen because I want this in a table, and if I make it too wide, it won't fit. So we're also going to put the optimal architecture. Architecture. Okay. So I'm just going to do, 4 columns seems cheap. What the heck, we'll just do those 4 columns. The trick is, in order to do a custom view, I have to start with a piece of information. And I mentioned it earlier, but let's start at the very top of this view. First of all, it has a name. This can be anything you want. Doesn't matter. This decides what type of object will be displayed by this view. I need to put a type name in here. And by default, my little PS object doesn't have a unique type name, so I need to give it one. And that is how I have given it a custom type name. I'm now going to copy that and paste it into my XML right between type name and close type name. Now this view will be selected by this. I'm going to delete all these column headers so I can kind of start fresh. Now pay real close attention. This is where I miss people. You got to make sure you grab this singleton here, the one that's table column header that closes itself. Got to get rid of them all. I'm also going to go delete all except the first table column item. Now it's a good idea to take a look and make sure you don't have any red squigglies. It's also okay to stick in a little bit of white space if you want to. I find this can help separate things and make it easier to read. Here are my headers. Here are my row entries. So now I can start coming up with my headers. Computer. I'm going to let it calculate the width, and I'm going to leave it left aligned. Now I've said I wanted 4 columns total. So there's 1, 2, 3, 4. SP version. Oh, that's kind of crummy. Let's call it service pack. Actually, we all know what SP means, and it's always short. Let's just call it SP. Yeah, it's less typing. OS version. Yeah, I can have a space in here, and it's okay, because this is just a column header. And last, optimal architecture is really long. Let's do arc match, because it's a true or a false that goes into there. Now I need to decide what data is going to go into each of these. The first one is going to get the computer name property. So there's the first one. Copy, paste, paste, paste. The second column gets the SP version property. The third column, hello, gets the OS version property. And the last column gets the optimal architecture column. A couple of things to be careful with. In version 2 of PowerShell, these XML tags are case sensitive. Do not mess them up. I tend to just treat them like they're case sensitive no matter what version of PowerShell I'm using. That way I'm never wrong. All right, so I'm going to save this. I saved this. Let's go into the shell and we're going to test it. I need to, okay, I do have a command at the bottom of this script that's going to actually run the command. So I can just run the script, that'll run the command, and we'll see what it looks like. And it's in debug. Well, that doesn't look anything like what I told it to look like, does it? It's because I never actually loaded my custom XML into memory. See, every time you load the shell, it only starts with Microsoft's formatting instructions. Update format data, append myview.format.ps1xml. Now right here is where you might run into error messages. And I'm going to show you, I'm going to go mess up my file. I'm going to take this sacrifice for you. Table, column. Remember I told you about this one? This is the one that everybody misses. And here's what happens. There were errors. The header item count is 5. But that doesn't match the row item count of 4. Okay, where did this happen? Well, it's in here. You got to know how to do the math. You got to know how to count. 1, 2, 3, 4, 5. That guy can't be in there because that's a 5th column header, but I only provided 1, 2, 3, 4 sets of values. Well, here's another problem. Now that I fixed that and I saved it, make sure your little asterisk and the tab is gone. Saved it. Ooh. Now in version 2 of PowerShell, you may have to close the shell entirely before it will let you try to load it again. The little bug it had. Let's run my command. Look at that. Isn't that awesome? Now it's still kind of spaced out a lot. So what I could go do, I know my computer names are never longer than 10 characters. I know this is an easy one. Width 2. All right. OS version. What wasn't that information? Oh, 1, 2, 3, 4, 5, 6, 7, 8. It's got to be that long for the words OS version. That's why. Arc match can't be really longer. Computer name looks like it's long enough. So I saved that. Let's run it again and see if it changes anything. It won't, because it's still running off the old version that it loaded into memory. And you can't reload it. You've got to close the shell, open a new shell, and this is why I suggested you wanted to keep this thing in the root of your C drive so that it's easy to get to again. Update format data, my format, my view.format.ps1xml, no errors is good. Run debug. It cinched it in a little bit. It's still trying to leave a lot of room for this. So I might want to give computer a smaller width, and that would start to pull those things together and eliminate white space, or blue space. That's how you can create a custom formatting view. Now we're going to run through this entire process again using a slightly different example. Now in this example, I'm going to go use a module that I've written previously. So I'm going into my modules folder. Here's my OS Tools module. Let's open this with, oh, for heck's sake. Let's just open the ISE. Open Documents, Windows PowerShell modules, OS Tools, ostools.psm1. Okay. So I need to decide what I want to display as my output here. And this has got several properties. This is similar output to what we just looked at. We're going to do a list this time, and I just want computer name and manufacturer. And I'm doing that just so we can demonstrate the list style as well. So I've already decided the first thing I need to do is make sure this thing has a custom type name. And the name of this function is getSystemDetails. Now, it's important that all these object names be unique. And so what I'll often do is I'll come up with a 3-part name. The first part is my company name. In this case, it's lab. The second part is the name of the module, OS Tools. And the third part is the noun from the command name itself. So this is getSystemDetails. So this is a lab.ostools.systemdetails. So I'm going to save that. I'm going to come down here to a command shell and run get system details, computer name, localhost. All right, that's its default output. I want to modify that. Now this is going to require me to make a new file. And I'm going to save this in my C folder as ostools.format.ps1xml. There's no reason it has to be called OS Tools. The .format.ps1xml is important. You can call this anything you want to. I'm doing that just because it's easier for me to kind of tie these things together in my head when I'm looking at them. So I'll put that in the root of my C drive. And now we need to go into Microsoft's little file here so I can pilfer a few bits. And I do not like to leave hanging threads here. So I'm going to finish these tags up and make sure all the little red squigglies go away before I do anything else. Get lots of nice space in there. Now let's go find a list view instead of a table view that we can rip off. Oh, here's one. Ah, that was easy. So we're just going to grab this entire list view, and you can see it says list control right there. That's how I know it's a list view. Right to the closing view tag. Paste. Now we start up with the name. I tend to use the same name. The name doesn't matter a lot. There's a couple of little things that plays into, not that you see often. I'm just going to call it lab ostools.systemdetails because that's also my type name that I just gave it. And so then those things just kind of visually are more connected in my mind. All right. Now I only want 2 properties, so I can get rid of all but 2 list items. Now list items are a little simpler. You don't have to do the header and the entries. You just do the list. So I want computer name and I want manufacturer. I'm going to save that and then cop down to the shell. Run this again. No differences. Update format data. Append C ostools.format.ps1xml and then run my command again. And now I only get the 2 that I specified in the view. The rest are still there. I can format this as a table. It'll pull everything up. I can format it as a list and it'll pull everything up. This is just what I get when I don't tell it what to display. Just those pieces of information. Should be able to do this for another computer too. Yep, 2 different ones. So, okay, that's awesome. Let's close this. The problem I have now is that anytime I want that custom view, this custom view to work, I have to manually load it into memory. Not a big fan of that. I'm going to save it in the same directory as my module. So if we open a shell, I've got those same 2 files right in here. And the problem is PowerShell won't load them automatically. If I just try to run a command out of OS Tools, PowerShell will find it and it will load this file, the actual script module, automatically. It won't load this. I still have to do it manually right now. I can avoid that by creating a module manifest. This naming is important. Has to have a PSD1 file name extension. If it's in a folder called OS Tools, then the file name has to be OS Tools, just like the script file name has to be OS Tools. This one doesn't matter as much. The format file doesn't really care. So that's the path it has to be in. That's important. The root module is ostools.psm1. That's my script module. And formats to process is my custom view file. Now you'll notice I have a module manifest. Watch what happens. Get system details minus computer name, dc.lab.pri, and localhost. PowerShell found the manifest, loaded it. The manifest said, hey, you have to load this script and you also have to load that view. So they happen at the same magical time automatically. I think that's pretty neat. I think that's an awesome way to do it. Now, this script file I've got has actually got multiple commands, right? There's get system details, there's get disk details. I can put custom views for both of them into this same view file. I can stack them all up. What I would do is just grab this entire section, copy it, paste it, and then this one this would be the next custom view that I did. Now I don't actually need that, so I'm going to take it out. You can have as many as you want in there. All your views appear inside view definitions and configuration. They all go in between there and there. So now you can create beautiful output that's customized. I'll also note that when you do stuff like that, you'll notice in this disk info command right here that when I'm constructing my custom properties, I include a computer name, but I'm doing some math on the drive space. I'm converting the free space and the size into gigabytes. You might not do that. What you might do instead is leave the underlying value as raw as possible, And then for your default display, you can put a script block in here that converts the data into gigabytes. That way the conversion only happens by default. If somebody else wants to use this and they actually need the bytes, the raw data is still there, but your view just has it display differently by default. So with a quick look at how PowerShell's formatting actually works, it's fully possible to take some of that and adapt it to make your own custom views, remembering that views can only apply to objects that have a unique type name. So we're going to have to create a custom one on any objects we output. I also showed you how to load those manually, but much better is loading those things in a module manifest. You put your tools in a module, you put your formatting views in a module, you shake it all about, and then you can load it all at the same time. I hope this has been informative for you, and I'd like to thank you for viewing.